Dear students, in last class, I discussed difference between distance and displacement. To do more problems, in fact, typical problems based on displacement and distance travel can be solved with the help of sine and cosine rules. So I'll give all mathematical support which required to solve such problems in this video. Let us start defining circle. Circle is a locus of points which are at equal distance from a fixed point. That fixed point is called center of the circle, which is denoted with O, and that fixed distance is radius. And semicircle means so here this is a diameter which divides into two equal parts. So this half of the circle is known as semicircle. Sector means it is a part of the circle, right? And arc means this AB is the arc. So that's cut here. There is a difference between chord and a secant. So if you take this circle, here chord is a line segment that is part of the within the circle. And here, so this is another circle. And here is a line which intersect the circle. So line segment means part of the line. So this is defined as this line segment is chord, and this one is secant. So here major and minor segments. So here is a circle. So this region is called okay. Here chord AB divides circle into two parts. So smaller part is smaller segment, and this bigger part is called major segment. And here, so we should know relation between degree measure and radian measure. Coordinate axis. Here, this entire region divided into So 360 equal parts. So each part, this region is called 1 degree. That is 1 by 360th of 360th part of entire region. And here, 1 radian, how it is defined? If you take a unit circle, means unit radius. And length need not be 1 unit radius, even 2 units radius also, same thing. So radius is 2, arc length is 2, then angle subtended is 1 radian. Now, to cover 2 units arc length, angle subtended becomes 2 radians. To cover 3 units, it is 3 radians. But entire circumference is 2 pi r, which is 2 pi into 1, which is 2 pi radians. So that means 2 pi radian will cover entire region. 360 degrees also cover entire region. So that is 2 pi radians is 360 degrees. 1 degree is pi by 180 radians. So this is the relation between degree measure and radian measure. Here, angle made by the arc length. See, suppose here you fix a unit circle, so 1 unit radius. So here it is 1 arc length is 1 radian. Even if you take another circle, there is no change in the angle, but if it happens to be 2 units radius and arc length also 2. That means L is proportional to R for fixed angle. So that is L is equal to R theta. So it is the relation between length of the arc and radius. Right. Here it is another important point. Once 2 sides are equal, let us say these 2 sides are equal, opposite angles, opposite to AB is theta, opposite to AC also theta. And another useful theorem is very useful. Quite on later on, we use this theorem applications. Angle subtended by arc of a circle at the center. Center is this. Is double the angle subtended by it any point on the circumference. Let us take one point on the circumference. O is the center of the circle. JB is the chord. What we have to prove here is angle AOB is 2 theta if angle ACB is theta. So let us see how this can be proved. Now, our intention here is finally what I have to prove is angle made by the chord AB at the center is 2 times angle made by the same chord on the circumference. Say this is just draw a line through C which meets circle center at O. Let us say this angle as alpha, this as beta. So then this is a radius, it is a radius, two sides are equal, opposite angles are equal. In fact, angle ACB is theta, which is alpha plus beta. And similarly, if this is beta, even this also beta, because these two are radii. And angle OCB, COB, sum of three angles are 180. It is 180 minus alpha plus beta. Angle COA is similarly 180 minus 2 alpha. Right. Now this angle will be angle at a point O is 360 degrees. Angle AOB is 360 minus 180 minus 2 beta, 180 minus 2 alpha, which is 2 beta plus 2 alpha, 2 times beta plus alpha, which is 2 theta. Therefore, angle made by the chord at the center is double the angle made by the chord at the circumference. Here, related to this, if you take this as a chord, this ACB will be one segment. Same segment means in this segment, at the end, if you draw chords, they meet circumference at, let us say, P. Here is Q. So here P and Q are angles in the same segment. So it is, say it is the center. If I say angle AOB is 2 theta, angle APB will be theta. Similarly, angle A cube also theta. Therefore, we say angles in the same segment are equal. So here in right angle triangle ABC, if you fix angle as theta, this becomes opposite. If you fix this C as an angle, AB becomes opposite. But now I am fixing angle at A, cos will be adjacent by hypotenuse. But this formula, if you take other than right angle triangle, here, if I write sine theta as BC by AC, it is wrong. I cannot write like this. First of all, hypotenuse is not defined in arbitrary triangle. So our major intention in this video is for any triangle, this definition is wrong, opposite by hypotenuse. For all other triangles, how to find sine, cosine angles. So here we have two useful formulas. One is cosine and other is sine. So let us derive those formulas. Here is A, here is B, here is C. Say this is X. It will be A minus X. H square is C square plus X square by using Pythagoras theorem. 1 minute. C square is H square plus X square from which triangle? Triangle ADB. So B square is h square plus a minus x whole square from triangle ADC. From this, from first one, I can write h square. From second one, I can write from these two b square minus, so minus x square get cancelled. From here, so I can say that c square plus a square minus 2ax. So here it is angle B. Cos B is this, x is c cos B. From here, B square is minus 2ac cos B. This is cosine rule. Not only B, it's nothing but one side square is, so sum of remaining two side square lengths minus 2 times product of them and cosine of angle between them. So here A, if you take remaining B square, C square and included angle A. Suppose you want to write C square, remaining two side squares sum minus product into, here small c is there, C is the angle. That is between A and B, C is angle. So this formula is more useful for even for right angle it is okay, for any other angle also it is okay. For example, if I take 3, 5 and say this is A, B, C, 7, find cos A means this is included angle. Those two sides minus 2 times 3 into 5 by 3 into 1 minute. Here minus 7 square by 2 into 3 into 5. After simplification, 34 minus 49 minus 15 by 30 minus of, we say that angle A is 120 degrees. So this is how we find cosine of angle for arbitrary triangle. Opposite by hypotenuse, those adjacent by hypotenuse, those formulas are not valid here. So in a similar way, how cosine rule helps, in the same way, sine rule also help for any triangle. If you consider a triangle, here it is AB, C is some point on the circle. So now you take a triangle ABC. Triangle is inscribed in a circle which is called circumcircle of triangle ABC. Center is here. Radius is this. Now, to derive this rule, I am drawing a diameter through the center, and very important point here is 180 degrees. Angle at the center is 180. Here it will be 90 degrees by earlier theorem. That is, angle in a semicircle is 90 degrees. And another theorem statement, angles in the same segment are equal, P equal to C, since angles in the same segment are. Now, if I take triangle APB, it is a right angle triangle, sine P, which is same as sine C, opposite is AB, hypotenuse is AP. So AB we denote with C. So missing letter. So that's how standard notation goes on. From here, AB is nothing but C by 2R is equal to sine C. That is C by sine C, which is 2R. Similarly, the same thing we can apply for other side, and we can prove that A by sine A, B by sine B, C by sine C is 2R. Now, once you know these basic mathematical basics, based on that, we can solve typical problems related to displacement and distance travel. Not only this, in optics also many places these concepts are useful. If you take here a circle, a particle is located at A, and it moves through an angular displacement 60 degrees on the circular path. Let us say 60 degrees. What is linear displacement and distance traveled? Displacement is a shortest distance between AB. And to find out first question answer, suppose radius is 7, two sides are equal, opposite angles are equal, 2 theta plus 60 is sum of three angles, 180. From here, theta is 60 degrees. Once all angles are same, OAB is equilateral. Once triangle is equilateral, I can say that AB length also 7 meters. And distance traveled is nothing but arc AB, which is L r theta. R here is 7, theta is in terms of radian. So 180 degrees is pi radians, 60 degrees will be pi by 3. Theta we have to write number related to radian measure, 7 pi by 3. Now let us consider another example. It is the same circular path. So particle started at A, it makes an angular displacement 30 degrees. Earlier, it was 60 more comfortable equilateral. Now here it is 7 meters only. You can find arc length comfortably. Arc length AB is nothing but distance traveled, which is nothing but r theta. R is 7. 30 degrees is nothing but pi by 6 radians. So that is the distance covered. Displacement means shortest distance between AB displacement AB equal to, by using cosine rule, of remaining two sides square minus 277 into cos that. 98, 49 plus 49. So 49 into 2, again 98, cos 30, root 3 by 2. So that displacement is 49 into 2 minus root 3. So here what rule I used? Cosine rule. This is AB square. So this, which implies this is, I used cosine rule to find out it. Or the same problem also can be solved by using sine rule. Sine rule means x by sine 30 is equal to, this is radius, here radius. 30 means remaining angle is 150. It will become 75, 75. So 7 by sine 75. So x becomes 7 into sine 30 by sine 75. So this way also you can find uh, displacement. Here in this question, particle moves through a linear displacement root 3 on a circular path of radius. If you draw a circle here, we said linear displacement. There is a difference between angular displacement and a linear displacement. Linear means nothing but arc length, which is root 3 meters. It is 1, it is 1. Radius is 1. He is asking angle subtended. So root 3 meters, sorry, not arc length it is linear displacement, that is AB. By using cosine rule, cos theta is 1 square plus 1 square minus root 3 whole square by 2 times this, which is minus half. Theta is 120 degrees. So formula is cos A is B square plus C square minus A square by 2BC. Already I derived cosine rule. Same rule I am using. And the distance traveled is nothing but arc length, which is nothing but L equal to arc theta. Theta here is how much? 120 degrees. You convert in terms of radians, we get 2 pi by 3. So a person moves from A to B towards east. east, west, north, south at a distance 3 meters and then travel 7 meters towards northeast. So that is here it is north of east means east to north. In this direction, he traveled 120 degrees towards northeast. Then what is the displacement? So let me change the problem as 60 degrees north of east. That is east of north of east means east to north. 60 degrees and it becomes 120 and here 7 meters towards it. Let us change this distance also 5 meters. Then what is the displacement means? AC square is 3 cosine rule, 3 square plus 5 square, 2 into 3 into 5 cos 120 degrees. 34 minus cos 120 is minus half. 49 is 7 meters. So not only here, later on also, the sine and cosine rule plays a vital role in solving tough problems. So please go through all the what all I explained and try to upgrade yourself.